hello young people. So hopefully you already watched the video about the Pythagorean theorem and how to use it to find the missing side length of a right triangle. We talked about the formula is a squared plus b squared equals c squared, and that's if you're finding the hypotenuse. If it's one of the legs of the triangle that you're missing, you're gonna subtract and do the hypotenuse squared minus the leg squared. If you don't understand that concept yet, please do not start this video. Go back, find some more resources. This video is only for when you understand the basics of the Pythagorean theorem. All right, in this video, we're gonna talk about kind of how the Pythagorean theorem can be shown or presented to you in word problems. These are what you call real world situations. They might not be everybody's real world, but these are a little more realistic portrayals of what a Pythagorean theorem or how it could be used in the real world. So here I've got, and you can pause this and write it down if you need to. It says, a painter is using a ladder to reach the top of a house. The ladder is 15 feet tall and is placed 6 feet from the house. How high on the house will the ladder reach? So right now, it doesn't really seem a whole lot like a Pythagorean theorem problem. It kind of just seems weird. So what we're gonna tell y'all to do is to always use pictures. Draw what the problem's talking about. So okay, we've got a painter using a ladder to reach the top of a house. So first thing I'm gonna do is I'm gonna draw a quick house. I know, you didn't realize there was so much art involved in mathematics. Here you go. Here's my house. Okay, so a painter is using a ladder. Now, pretend my pen's the ladder. When you put a ladder against a house, do you lay it just like that? No, your ladder would fall over, you would not be able to climb it, that would not be safe. You have to put your ladder at an angle like that. So I'm gonna draw my ladder. I know what you're thinking. Miss Gothart should teach art. I know. Okay, so there's my ladder. All right, so then that's the situation. We've drawn it, yay. Now we're gonna go back into the problem to find our dimensions so we can start labeling things. It says the ladder is 15 feet tall. So, okay, so this ladder is 15 feet. 15 feet. Now I apologize if things are shaky. It is placed 6 feet from the house. Okay, so the bottom of the ladder to the house has to be 6 feet. Okay, what I want you to notice, and I'll use a pencil to kind of shade this, the house and the ladder make a right triangle. Right here. Your ladder is your hypotenuse. The house and the ground have a right angle. So this becomes a 90 degree or a right triangle. So we can use the Pythagorean theorem. We have our hypotenuse, we have a leg. So when you have the hypotenuse and have a leg, remember that means you're gonna subtract. So we're gonna do 15 squared minus 6 squared. Pause this and go ahead and do that just to make sure you know how to do your calculations correctly. Pausey pause. All right, so 15 squared minus 6 squared, you get 189. Remember, you have to take the square root of it. You get approximately 13.75. So this ladder with these dimensions on it will reach approximately 13 3/4 feet up on the house. That's how high he'll be able to get on the house. All right? This is usually called the ladder problem. It's a very popular Pythagorean theorem problem. I don't know why, but you'll see it a lot. All right, here's another one. I want you to go ahead and pause this and write this problem down, please. Rebecca left her house and walked 2 miles north to the grocery store. When she was finished, she walked back home. From home, she walked 4 miles west to her friend's house. Approximately how many miles is her friend's house from the grocery store? Again, it sounds bad until you draw it out. I know some of you can see through the paper, ignore that. All right, so we've got a little house, right? This is Rebecca's, so I'm gonna label it. Rebecca's house. Okay, it says she walked 2 miles north. Now, when you think about your directions, you should know north is straight up, So we're gonna start at Rebecca's house, and we're gonna go north, and right here is gonna be the grocery store. I'm gonna write store. And we said she had to walk 2 miles. She's walking a lot. That's not fun. 2 miles. All right. And then it said she walked back home. All right. So we're back at Rebecca's house. From home, so from here, she walked 4 miles west. All right. So west would be that way. Ooh, so I did my labelings bad. That's fine. You're just gonna have to bear with me. It would have been better if I went east, but it's fine. All right, so she went west. We're going this way, right? 4 miles to her friend's house. So I got another little house. This is friend. And that's 4 miles. Hopefully your picture looks better than mine. Sorry, guys. Approximately how many miles is her friend's house from the grocery store? So we want how far her friend is from the store. Oh, look, I have made a right triangle, right? From the store to Rebecca's house is 2 miles. That's one of our legs. Rebecca's house to her friend's house is 4 miles. That's another leg. And then from the friend's house to the store in that straight line is our hypotenuse. So we're gonna do a squared plus b squared equals c squared. Pause this and do your calculations, please. All right, here's what you should have. 2 squared plus 4 squared equals 20. We've got to take the square root of it, because remember 20 would represent c squared. We don't want c squared, we want just c. How you unsquare something is the square root. So her friend lives approximately 4.47 miles from the grocery store. That's that distance right there. As always, if you have any questions about this, you are more than welcome to email your teachers. There's also so many practice problems online. You have an IXL to work on over this. Remember, IXL will tell you when you've got something wrong, and it'll explain the problem to you. So make sure you are reading those explanations. Let us know if you need anything.